Hey guys, welcome to this episode on AWS networking or AWS VPC, Virtual Private Cloud. So to explain the concepts, I thought of going through a practical use case where a particular company, let's call it ABC company, is trying to migrate the existing on-premises network onto AWS. So this is the outline. First, let's talk about the on-premises network architecture of that conceptual company, and afterwards, let's try to model that on-premises architecture on AWS cloud using different construct of AWS VPC. And in the next video, we'll talk about how to secure that cloud network architecture using network security control list and security groups and different other construct that is available to you in AWS cloud. Alright, so let's get started. So this is our company. Let's call it ABC. So in our ABC company, they already have this setup in the network. So they have this particular IP range. So that's a /28 IP range. And if you're not familiar about this CIDR block, we will get to that as well. So for now, let's say they have some address space or IP range, and that range is further divided to two subnetworks. So this is one of the subnetwork and the other one is this one. So this we call subnets for short. So as you can see, this company has their web servers in one particular subnet, and that is protected by a firewall. So users from internet can directly talk to the web server. Obviously, it's the web server, so they should be able to talk to the web server in order to view website of ABC company. But this particular subnet can only be accessed by the web server, and it does not have a direct connection from the internet, as you can see. So why have they done it like that? Because in that particular subnet they have the application server, database server. So normally we are not allowing direct access to our database from internet. So that's what they have only given access to their web servers via another firewall to access the database and the application server. So this is the setup, and they want to migrate to AWS. So the sysops guys of this particular company has created an AWS account in AWS, and they are thinking of creating two EC2 instances for web server and for application server and database server. So what they have done is they have created these two servers, web server and another backend EC2 server. And by default, when spinning up EC2 instances, AWS uses its default VPC because all the EC2 instances spinning up by AWS must belong into a VPC. So when you spin up EC2 instances, if you do not specify a particular network or a VPC, AWS will put them into a default VPC, and they will create a public subnet in that particular VPC and put these EC2 instances. But we are going to create our own VPC and create our subnets and set up our network and then place our EC2 instances in the network. So in AWS, we have full control over our VPC. So what really is a VPC, guys? We can consider VPC as a virtual data center in AWS cloud. So in VPC, you have the full control over setting up your network, setting up your security, spinning up different resources in the network, and everything is under your control. And also, it is isolated from other AWS customers. So if you set up a VPC, that is your private environment, and no one has access to your VPC unless you provide access explicitly. So let's create the VPC. So when you create a VPC in AWS, it is always associated with only one region in AWS. For example, in this case, this VPC is belonging to Ireland region or EU West 1 region. So you cannot have VPC spanning across different regions. So that is one of the questions that you will be tested in the examination. A VPC is always belonging to a one region. And when you create a VPC, you have to define your IP address range. And if you can remember, our on-premises network had this IP address range. So this IP address range. Similarly, we have to have an IP address range for our VPC. So in this case, we have defined this particular IP address range 10.0.0.0/16. Now, this is a private IP address range. Can we use another number like 11.0.0 something? Yeah, of course you can, but there are some standard IP address ranges, and it is always recommended to use these standard IP ranges, and we call them IRC 1918 standard. So in this particular standard, they have several IP address ranges. One is obviously this one, 10.0.0.0/16. And also we have 172.16.0.0/16, and we have 192.168.0.0/16. Now the format that we have used to define our IP address range is called a CIDR block or CIDR block. So let's try to understand this. So this is 10.0.0/16 CIDR. So in this CIDR block, this 16 represents the 16 bits for the network. So as you know, an IP address is consisted of 32 bits, and out of those 32 bits, 16 bits are reserved for the network in this CIDR block. So the standard way of representing 32-bit IP address is using 8-bit blocks. As you can see, this is one block, another block, third block, and the fourth block. So the first two blocks is comprised of 16 bits, and that is reserved for the network, and the rest of 16 bits is allocated for the resources. So that means the first two blocks cannot be changed. So that means 10.0 will stay for any IP address in our IP address ranges, and the last two bits can be changed. So let's take example. So what is the starting IP address? So the first IP address is 10.0.0. And how do we count the total IP range of this CIDR block? So that's a very easy calculation. So the easiest way of calculating the total IP count is consider this last number, in this case /16, or it could be /24, and then deduct it from 32. Then you will get the bits allocated for your resources or your hosts, and then take the power of it. In this case, 2 to the power 32 minus 16, that is 2 to the power 16, 65,536. So what is the last address? I told you only last two octets can be changed. So one octet is 8 bits, so that means 255, and the other one is also 255. So you can see the first two octets are never changed because those are reserved for the network, and these two will change. So what is the range? So it will start from 10.0.0 and it will go up to 10.0.255.255. So this is your full IP range that is supported by this CIDR block. Well, one other thing you should understand is although you have this full address range, now 65,536 IP addresses in this range, you cannot use all those IP addresses for your resources because AWS reserves 5 IP addresses from this. So it will reserve the first 4 IP address, that means 10.0.0.1 and 2, 3 and 4. So those 4 addresses and the last IP addresses, which is this one. So other than those 5 addresses, you can use any of these IP addresses inside your VPC. And another thing you must know is the maximum CIDR that AWS supports is /16 and the minimum is /28. Okay, so in /16 you get 65,536 IP addresses. In /28, which is the minimum value that VPC supports 16 IP addresses. Right, let's get back to our diagram. Now this is our VPC IP address range as we have seen. Then let's create two subnetworks within this VPC. You can create multiple subnets inside a VPC, and you have to remember, as VPC is always corresponding to a region, a subnetwork is corresponding to a availability zone. So subnet must always be associated with a single AZ or availability zone. So a VPC associated with a region and a subnet is always associated with the availability zone, right? In AC1, availability zone 1 is dedicated to the subnet 1, and availability zone 2, because in a region you have multiple availability zones. So in, let's say, availability zone 2 is associated with this particular subnet 2. So this is our main CIDR block of our VPC 10.0.0/16. This slash 16 can further divide it to smaller fragment of network in these subnets. So in this case, 10.0.0.0/24 is allocated to one particular subnet, and 10.0.1.0/24 is allocated to another subnet. Now you need to remember another important thing is these IP ranges that we have allocated to different subnets cannot overlap. So what do you mean by overlap? That means any IP address within this range cannot be same as another IP address in this range. So let's take a look. So the starting address is 10.0.0.0, and the total IP count, how do you count it? So you can subtract 24 from 32. So that means you have only 8 bits for allocated for the host. So taking 2 to the power 8, so that is 256 IP addresses. And since the IP addresses are starting from 0, so the last IP address that could go up to is 10.0.0.255. So the range is this. And let's consider the other one as well. So the starting address is 10.0.1.0, and again, since it is /24, number of IP is 256. So the last or ending IP address is 10.0.1.255. So if you consider these two IP address range, you can see none of these IPs are conflicting, right? Because in this range, only the last bit changes, and in this case, the third octet value is fixed to 1, and the last bit again changes. So this is a perfectly valid CIDR ranges where we can allocate it for our subnets. Good. So now let's divide our VPC into subnetworks. Okay, now take a look at this diagram. So here we have our VPC, and we have created two subnetworks /24/24, the one we just saw, and each subnet is associated with the availability zone. So this is the subnet, and this is the availability zone, AZ1, and this is the second subnet, and this is the second availability zone. So once you create a VPC, there will be a VPC router automatically configured for you. So this VPC router is basically allowing the communication between the subnets of this VPC. It will make sure subnet 1 can always talk to subnet 2. So we'll get into that in a bit. I'm not sure if you have seen it. I have put the web server, this, in the subnet 1, and the backend server in the subnet 2. Well, when you spin up resources like EC2 instances in a subnet, they will be associated with the IP addresses from the subnet's IP range. Take a look at this example. The web server got associated with this IP address 10.0.0.8, which is within this range, and this is not a reserved IP address as well. The backend server also allocated another IP address from the subnet 2 IP address range 10.0.1.15, which is again not a reserved IP addresses, which is not one of the first 4 or last IP address. And I told you this VPC router allows the subnet 1 to talk to subnet 2. So that is made possible by a routing rule in this VPC router. Let me show you that. Take a look at this route table that is associated with this VPC router. So each subnet must be associated with a route table. So that's another thing that you must remember. For example, you can see this subnet 1 is associated with this route table, and this subnet is again associated with another route table. And both of these route tables, you can see there's a rule or a record saying that if a resource in this particular subnet is talking to another resource which has the destination IP address within our VPC's range, that is 10.0.0.0/16, this route within the VPC. So that's what local means. So if this resource, let's say our backend server 10.0.1.15 is talking to our web server, which is within this range, and it says route it within our VPC. So that makes backend server to talk to web server. And similarly, in the web server also, we have the same rule. If the web server or whatever the resource is talking to another resource where its IP range falls into this IP range, which is our VPC IP range, just route it locally or route it within the VPC. So it can also talk to backend server since backend server's IP address is falling within this IP range. Hence, any resource within a subnet can talk to any other resource within another subnet inside our same VPC. Alright, so let's continue. Now we need to allow users to talk to our web server over the internet. So how can we make this possible? So in this case, we have to set up an internet gateway for this particular subnet 1 because our web server is in the subnet 1. So we have to connect or configure a internet gateway in the subnet 1. So next, let's look at that. Setting up an internet gateway. Here we go. So this is our internet gateway. So that is another appliance or construct in VPC where we can use to allow our resources to communicate to internet and also from internet into our resources inside the VPC or the subnet in particular. So internet gateway is a managed service which is highly scalable. So this is managed by AWS, so you don't find any single point of failures at this point. And you can associate an internet gateway with a subnet. So how do we do that association? Well, if you can see, I have moved the VPC router from here to here, so it will be more clear. So what we will basically do is we will create another route entry in the route table associated for our subnet 1 that points out to internet gateway. So let's have a look at it. So this is our currently associated route table for the subnet 1. We already seen if there's any traffic destined to our VPC, we are routing it locally or within the VPC. And we can set up another rule. If there is any other IP address that our server is talking to, always take that to the internet gateway. So by putting 0.0.0.0/0 indicates any other IP address except an IP address in this range. So if our web server want to talk to the internet, so it will be an appliance or a server or another machine which has a different IP addresses which fall into this rule, and it will be routed to the internet gateway here. Then from the internet gateway that will be routed to that particular appliance or an server. Similarly, the incoming request will also be routed through the internet gateway into our subnet. Now guys, can you see I have named this subnet as public subnet. Why did we call public subnet? We call a subnet as a public subnet if it has an internet gateway attached and the route table has an entry to the internet gateway. We call a subnet a private subnet if it does not have an internet gateway attached or it does not have any routing rule to the internet gateway. So our second subnet is a private subnet because it does not have any association with the internet gateway. Hope it is clear. Now one other thing I want to clarify. You can see we have used this 10.0.0/16 range for our VPC. Can another customer use the same range? Of course he can. But in that case, how do we uniquely identify a resource in our VPC from another user's VPC? Because there could be another EC2 instance with the same IP assigned to that, let's say 10.0.0.8 in his VPC in a subnet. So how does a resource in the internet uniquely identify our web server and the other EC2 instance which has the same IP? So that is again made possible by internet gateway. So internet gateway does something called NAT or network address translation. Since internet gateway is the first point of contact, we have to assign an public IP address at the internet gateway level, or we call it an elastic IP. Elastic IP is a public IP that we assign to internet gateway. So the outside resource of the internet will only see the internet gateway's IP address or the EIP. So the internet gateway will map that elastic IP to the whatever the private IP address belonging to the server. So the other user's internet gateway elastic IP is always different because it's a public IP. So public IPs are unique. And that public IP can also map to his web server's private IP address. So that's how there won't be any clashes when communicating between resources within the same CIDR block. Alright, so let's move on. Next, we are going to set up a NAT gateway. So what is a NAT gateway, guys? So let's take this example. Now, we already mentioned in a private subnet, we do not have an internet gateway attached. So the outside resources cannot directly communicate to the server. But these EC2 instances, so in this case, the backend server will have our application server and the database, right? So those application server and the database has to maybe run some updates. For example, let's say the database version has to be upgraded. So in that case, this EC2 instance has to communicate with the internet and grab that update and update the database. But it does not have any connection to internet. So how can we make this backend server to connect to internet and get the database updates while any of the resources from outside internet cannot directly access the backend server? So that is made possible by a NAT gateway. Now you can see there's this another appliance called NAT gateway. This is another managed service. So AWS has NAT gateways and NAT instances. So NAT instance is another EC2 instance, but it is not as highly scalable as NAT gateway. So NAT gateway is a managed service which does not have any single point of failures. So the NAT gateway is always placed in a public subnet, and we are creating a route to the NAT gateway in the private subnet. For example, earlier it had only this route, and we are assigning another route which says any other IP addresses outside this VPC CIDR point to the NAT gateway. So for example, let's say our database server wants to talk to MySQL site to get the latest MySQL update. So that points to a different IP address, right? Because that MySQL site has a different IP address. So it will take to the NAT gateway here, and from the NAT gateway, it will talk to the internet gateway here, and it will fetch the update and come back and back to the NAT gateway. In NAT gateway, it does another network address translation here and find the private address of the backend server and send back the updates. So that's how we make the servers in a private network to talk to internet. So I hope you understand this. So by now we covered so many things. So we'll take a look at the things that we must remember for our exam. So I prepared a list of points to remember for the exam. So let's go through them. The first one is VPC is a virtual network in AWS cloud, and it is isolated from the other AWS customers. We already know. And you have the full control over your VPC. As we have seen, we can set up our network, we can choose our IP address range, we can set up the security. The security part we will be covering in the next video. And here's another important thing. One VPC is always belonging to one region. So VPC cannot span across regions. But a VPC can have multiple subnets. And again, a subnet is belonging to a one availability zone. A subnet cannot again span across the availability zones of that region. And also a subnet must be associated with a route table. We have already seen that. A route table can have multiple associated subnets. So we can define our custom route tables, and we can associate those custom route tables with multiple subnets if we want. And also routing inside the VPC is always possible with the VPC router. We have seen that. Let's move on. So these are the VPC constructs. So VPC has the IP address range, the CIDR block, VPC router, VPC route table, internet gateway, security group, network access control list, and virtual private gateway. So these three we'll look at it in the next video. And the maximum CIDR range for the VPC is /16, and the minimum CIDR range is /28. So remember these points, guys. And also we talked that a subnets cannot have overlapping IPs, and also AWS reserves 5 IP addresses from your VPC CIDR range, the first 4 IPs and the last IP. And also if you can remember, I said it is recommended to use the private IP ranges from the RFC 1918 range, which is these 3 ranges. And this I didn't mention, but it's very important. You cannot change or modify the CIDR block of your VPC after you have created it. So when you create your VPC, it's recommended to use a large CIDR block. So in future, you don't have to worry about like modifying your CIDR blocks. But however, recently AWS announced that VPC CIDR blocks can be extended. You can have like up to 5 secondary CIDR blocks associated with your VPC. We talked about Internet Gateway, and it is a fully managed, highly scalable service, and it does network address translations as well. And in the next video, let's look at how to secure our cloud architecture with security groups and network ACL. Now I have a question for you guys. So we mentioned that web server is in the public subnet where the internet gateway is attached. So can someone outside our network access to our web server via internet? Just think about the current setup that we have right now. Well, the answer is no. The reason is, guys, we yet have not defined the security for our network architecture. If you can remember our on-premises network, we had firewalls, right? So we had a firewall for our web servers, and also we had a firewall for the backend servers. So when we migrated to AWS, we have to define firewalls as well. And in those firewalls, we have to define who can actually access our web servers, on which ports, and over which protocols. Unless otherwise we define those security aspects, our instances cannot be accessible over the internet. So let's look at what are the ways that we can secure our cloud network architecture. Now in AWS, there are two main constructs. So those are NACL, or NACL we call it, and security groups. So NACL stands for Network Access Control Lists, and security groups are basically the virtual firewalls. So our on-premises architecture had firewalls here. So similarly, we have virtual firewalls and we call them security groups in AWS. Now, let's say this is one of our subnets. Now I have drawn only one subnet and I have spin up two EC2 instance in that subnet. Okay. Now this subnet is within our VPC and it has a VPC router attached as well. Now guys, once you have spin up an instance, let's say EC2 instance inside our subnet, how can it really talks with the subnetwork? So that is nothing but via a ENI. So ENI stands for Elastic Network Interface. If you take a physical server, it always has a network interface card. We call it NIC. So this is the virtual network interface card which is attached to a virtual server. So obviously in a virtual server we cannot have NIC directly attached because it is virtual. So we need to have a virtual NIC, and which is called ENI, Elastic Network Interface. So ENI is the interface that our virtual servers EC2 instances talk with its subnet. Now security groups operates at ENI level. Can you see? Security groups operate right here. So what really is a security group and what is the purpose of that? Well, a security group is a virtual firewall and it controls what traffic comes into the instance and what traffic goes out of the instance. So it either allows traffic or either block traffic that is coming in or out of this particular EC2 instance. So security groups operates at the instance level, especially at the ENI of the instance, and it gives you the control to define inbound and outbound traffic rules to your EC2 instance. So inbound is the traffic coming into the instance and outbound is traffic going out of the instance. So what are the points that we have to remember here? First, and the very important point, is that security groups operate at the EC2 instance level, at the ENI of the instance in particular. And security groups are virtual firewalls and they allow or block traffic in and out of the EC2 instance. And here, an instance can have up to 5 security groups. So if you have more than one security group assigned to a EC2 instance, AWS will always check all the security rules before sending traffic into the instance. And then security groups are stateful. So that means if you allow an inbound traffic on a certain protocol for a certain port, you do not have to specify the return traffic through that port over that protocol again. So once you allow the inbound traffic, security group will make sure the outbound traffic is also allowed. Now this is different in network access control list. In network access control list, they are stateless. So in that case, although you allow an inbound traffic on a certain port, you have to explicitly mention allow or block the outbound traffic as well. And in security groups, it has only allow rules. You don't have deny rules, but in network access control list, it has both allow and deny rules. Now, if no rules is defined in a security group, the traffic is blocked. So it's never allowed any traffic into the instance if there's no rule is defined for a security group. Now, these are the main important points that you have to remember in terms of security group. So let's move on. How about NACL? Now, we learned that security groups operate at ENI of a EC2 instance. Now, NACL operates at the subnet level. NACL is like a gatekeeper, right? So the traffic is flowing from in this direction. So it will first meet the NACL that is operating at the router or a subnet level, and then only it will meet the security group at the ENI of the EC2 instance. So if we consider the EC2 instance, the first level of defense is the security group, and the second level of defense is the NACL or network access control list. Since NACL is defined at the subnet level, all the rules that we define at the NACL is applicable to all the instances or all the resources inside the subnet. So let's see what are the points that we need to remember. The very first one is the NACL operate at subnet level. So it's basically a gatekeeper of the subnet. NACLs are stateless, as I mentioned earlier. The return traffic has to be explicitly allowed even though you allow the inbound traffic. And unlike security group, NACLs can have both allow and deny rules. So if you are to deny a certain traffic from an IP address, so let's say that you know an IP address or an IP address range that you want to block from your network. So in that case, you cannot use security group because it does not have the deny rule. So there you have to use NACL because it supports deny rule. And here's another important thing. NACL rules are evaluated from the lowest number to highest number. So in NACL, when we are defining a rule, we have to specify a number. So those numbers can go from 10, 20, or it can go from 100, 200, etc. Right? So when evaluating those rules, AWS will start from the lowest number and it will go to the highest number. And the most important thing is AWS will directly apply the rules defined at the lowest numbers immediately. So the lowest numbers have the highest priority. And we discussed this. NACL rules are applied to all instances within the subnet because it is defined at the subnet level. So when you're architecting your application, it's best to list down all your resources and then decides who needs to talk to whom. And then we can create security groups and network access control lists depending upon that communication pattern. So now let's add security groups and network access control lists to our architecture and control the communication in our network. So here's our network architecture, and we are going to add a security group to our web server. Remember, security group is applied at the instance level, particularly in the ENI, and we are going to create a security group that allows traffic on HTTP protocol on the port 80 from any source. So now what is a source here? So source is any resource or any appliance that is trying to communicate to our instance. So that is where the request is originated, right? So the first rule says no matter whatever the resource is, no matter whatever the IP address, please allow HTTP traffic on port 80. Since this is a web server, we must have to allow this. Otherwise, they cannot access our web server. Similarly, we are going to allow HTTPS traffic as well from any source. So once we define this security group, our web server can be accessible over the internet from HTTP or HTTPS protocols. Now, one thing to remember, guys, here we did not specify NACL rule because when you create a VPC, it will create a default NACL that will allow all inbound and outbound rules. So here we just have to define our web server security group and configure these two rules. Then it is accessible over the internet. So what about the backend server? Do we really won't allow anyone in the internet to access our backend server over the internet? Do we really need this? No, right? Because our backend servers is consist of our databases, application servers, etc. So if anyone can access our databases over the internet, so that will be a real security threat. So instead what we will do is we will allow only the web server to access our backend server. So how can we do that? Basically, we have to define another security group for our backend server. Here we go. So we created this backend server security group which allow all TCP on the port 4000. So let's say our backend server is running on port 4000. So we define the port 4000 and which source do we allow it? We are allowing any resource that has the web server security group attached. So that is what this web server security group label means. So when you define a security group name, instead of an IP address or an IP address range, AWS will make sure to apply this rule to any resources that has this security group attached. So in this case, web server security group is attached to web server in this instance. So when the web server is trying to talk to the backend server, this rule will be evaluated. Alright guys, so now one other thing you have to notice is both these rules in these two security groups are inbound security rules. So that means these rules are applicable to the traffic that is coming into the instances. Here we did not specifically define our outbound rules because of the statefulness feature in security group. So that means if we allow HTTP on port 80 for any IP address, the return traffic will also be allowed. Alright, so I think now you guys have understood all the theoretical parts. Now it's time to practice it. Okay guys, now I am in the AWS console. So the very first thing that we have to do is to spin up a VPC or a virtual private cloud. So I will go to services and select VPC or type VPC, then select it. So that will take me to the VPC dashboard. So in the dashboard you should see how many VPCs available in this region. So I am currently in North Virginia region and there is this default VPC available in the North Virginia, and also in all other regions there's a default VPC that is created by AWS. We will explore more about default VPCs and custom VPCs in upcoming videos. For now, let's go into our VPCs, and here's our default VPC. So what are we going to do? We are going to create our new VPC. I'll click create VPC and you can give a name here. I will type YouTube. So my VPC name is YouTube, and this is the place where we need to define our CIDR block or IP range for our VPC. So let's use this particular IP range, that is 10.0.0.0/16. So /16 is the largest IP range that we can define in a VPC. And for IPv6 block, we don't need IPv6 addresses for now. So if you select IPv6 addresses, those are public IPv6 addresses, and that is managed by AWS. For tenancy, we will choose default because we don't want dedicated hosts to host our VPC, but we are going to use shared resources. Click create. Okay, VPC is created, and if you click on the VPC ID, that will take you to the VPC dashboard. So this is my VPC YouTube, and if I scroll to the right side, I should see the default component that is created by this VPC. So together with this VPC creation, it has created, or the AWS has created, a main route table and network access control list or NACL and DHCP options set. Now DHCP option set is used to pass configuration onto the EC2 instances that we launch in subnets of this network. And main route table is basically how are we going to route between subnets and subnets to outside world. And network access control list is the subnet layer of defense. So we'll talk about this while we are spinning up other resources. So we have the main network now, or now we have the VPC here. So what do we need to do next? We have to divide that main network into subnetworks. So here we have two subnetworks. We have a public subnetwork and a private subnetwork. So let's create two subnetworks. I will go to VPC and go to subnet section on the left side, and there are some default subnets you can see they are belong to the default VPC, but we are not going to use this one. Instead, we are going to create a new subnet. So let's call this subnet public subnet, and we have to choose the VPC. So we have to select the YouTube VPC we just created, not the default one. And then it will show, okay, this is the CIDR block of the VPC. So in the IPv4 CIDR block for this subnet, we have to define how are we going to break this main network IP ranges into subnetworks. So let's divide it like this. Let's use 10.0.0.0/24 as the range of this public subnet. Now /24, in the last video we learned how to calculate the starting IP address and the ending IP address of a CIDR block. Briefly, /24 will indicate how many IP addresses. It's basically 2 to the power 32 minus 24 IP addresses. So that means 2 to the power 8. That means 256 IP addresses. So the first IP address would be 10.0.0.0 and the last IP address would be 10.0.0.255. If you need a refresher, go and watch the previous video. So let's use the /24 for public subnet. Now for the availability zone, we can choose one of these availability zones that is available inside this North Virginia region. Now we learned that a subnet must be associated with one availability zone. If you don't have a preferred availability zone, just pick no preference, then AWS will use one of the availability zone for us. So let's use that and click create. Subnet is created. This is the ID. If you click onto that, you should be directed to the subnet table. Now, if you scroll to the right, you will see available IPv4 addresses is only 251. So what happened to the other 5 addresses, guys? Well, we discussed now AWS will reserve 5 addresses for its different purposes. Basically, it will reserve first 4 addresses, that means 10.0.0.0 through 10.0.0.0.3, and also the last IP address. So if you take out those 5 addresses, only 251 is left for us to use. Alright, and you can see the VPC that is associated with this public subnet is YouTube. Oh, good. So let's create our private subnet as well. I will type private subnet and VPC, YouTube VPC, and now let's choose 10.0.1.0/24 as this private subnet's IPv range. So AWS should allow this because we don't have any conflicting IP addresses within our public and private subnet ranges. Very nice. Now if you go here and click select a VPC, you should see your YouTube VPC as well. In this case, it's not loaded yet. So let's do a quick refresh. So once you refresh the page and click on this, then you should see the YouTube. So this is basically a easy filter where you can filter by the VPC. Then it will show only the subnets that belongs to that particular VPC. Here, our private subnet and our public subnet. Great. So what is the next thing? So we have our main VPC and public and private subnet. And NACL is already created for us by default with the creation of VPC. So let's check that. If I go to your VPC section and YouTube VPC, if I scroll down, our main network access control list, click on the link, and that will take me to the NACL page. And here's the default NACL that has created for us. Let me name this one YouTube NACL. So this NACL is associated with both of our subnets. And let's see the inbound rules. So inbound rules are basically what traffics this NACL allows into our subnet. So basically you can see all traffics has been allowed by any source into our subnet. And you can also see there's explicit deny rule here, but how NACL operates is start evaluating the rules from top, and if it finds a particular rule, in this case rule number 100, that allows all the traffic, then that rule will be applied to the subnet. Okay, so we have our NACL. And let's check the outbound rules as well. So outbound also everything is allowed. So any traffic can go out of our network or our subnets without any issue, without any restrictions. Of course, this is not a good security practice, but for this particular video, we will use this default NACL. And next we have an implied router, and this implied router has two route tables associated with that. Let's designate this particular subnet as a public subnet by attaching a route out to the internet. So how do we do that? We are going to create a route table, or we are going to use the main route table associated with this subnet, and then we will direct all the traffics that is going out of the VPC into the internet to our internet gateway. Let's do that. So let's go back to our VPC here. So in the VPC, you should see we have a main route table. Let's click on the route ID or the route table ID, which will take us to the route table. You can of course select route table here as well. And let's name our route table as YouTube route table RT. And you can see it is associated with our VPC, YouTube VPC. And if you go into the routes, we can see what are the default routes that is attached. So as you can see, this particular default route table has a route to the destination of 10.0.0.0/16. So what is this IP range? So this is basically the IP range of our VPC. So if any traffics that is bound to one of these IP addresses in this particular range will be directed to the target local. So local means our VPC itself. So any traffic that is generated inside the VPC to an IP address within the range of our VPC IP address range, it will be targeted within the VPC. So that makes sense, right? For example, look at this. So let's say our backend server wants to talk to our web server. So it will send a request. So that request will first go through the security group. And if it is permitted, it will go to the network access control list, our subnet protector. And if it is allowed, then it will go into our main router here. So in the router, it will check the route table that is associated with our private subnet, because the traffic is originated from the private subnet, right? So it will check the private subnet route table and see where it should route that particular request. Now let's say the web server's IP address is 10.0.0.8. So backend server request will have that IP address since it is talking to the web server, right? So the router will look at the route IP address, which is 10.0.0.8, and then it will check the route table. For example, let's say our private subnet is associated with this route table, and it will see the matching destination because 10.0.0.8 belongs to this range, and then it will route it within the VPC. That means it won't send it to the internet gateway, it will route it within the VPC, and this NACL or the web server NACL will receive that request and it will send it into the security group, and if the permissions are given both NACL and SG, it will go into the web server. Now guys, this route we cannot delete it. You see, I click edit, there's no any delete button there. But any other routes that we specify here, we will have a delete button. Alright, so now what we want to do? We want to associate our public subnet with our route table. So currently, I don't have any subnet associated with this route table or default route table. So let's go to subnet association and click edit subnetworks, and I will select public subnet here and I will associate that with this route table. Alright, so it is now associated. Now if I go into the routes, our local route is fine. So what about our internet bound traffic? So if now we need to create an internet gateway here and direct all the routes that is destined to internet and point those traffic to internet gateway. But wait, we don't have an internet gateway yet. So let's create the internet gateway first. So I will go to VPC dashboard, and if I go to internet gateway section on the left sidebar, I can select create internet gateway. Let's give it a name, YouTube IGW and click create. Now we learned that this internet gateway is a managed service, and if I refresh the page I should see our YouTube internet gateway IGW. Now look at the state. The state is detached. So in order to use this internet gateway within our VPC, we have to attach this internet gateway to our VPC. So I will select this and go to actions and attach to VPC. Then you should select the YouTube VPC and click attach. Alright, so it is now attached. See, YouTube VPC is attached to YouTube IGW. Now guys, we can go to our route tables and go to YouTube RT route table. Oh, I will rename this, guys. I will rename this to public route table because this route table is associated with a public subnet. So let's go to edit routes. Now we can add another route. So all internet bound traffic, we can denote them as 0.0.0/0. So this means all the IP addresses. Since we have explicit IP range defined here, except this IP range, anything else, any other IP addresses will be denoted by this one. And then we need to target it to our internet gateway. Click internet gateway and you should see the internet gateway ID here. Select that and click save routes. Very nice. Now our public subnet is properly configured. Can we use the same route table for our private subnet? No guys, because our private subnet should not have a route out to the internet. We cannot use this same route table. So let's create a new route table. I will click create route table and here let's name it private RT and select the VPC YouTube and click create. Alright, close this one. So this is our private RT and it has only our local route, which is fine. So this is the YouTube VPC we created last time. For this VPC we created two subnetworks. If I go to subnets here and filter the VPC, you can see the private subnet and the public subnet. Now I selected public subnet and I go to the route table that we associated with this. So basically you can see it is associated with the public route table, which has a route out to the internet for all the traffic other than the traffic from the VPC. Now let's select private subnet as well, but currently it is still associated with the public route table. So let's change that. So I will click edit route table association and in the drop down table let me select the other route table, which is our private subnet. You can see when I select this one, it has only one route out to the target local, which is within the VPC. And click save. Now the private subnet is correctly associated with the private route table. Great. I think now we are in a good position to launch two instances, our web server instance and the backend server instance on these two separate subnets. So together with that, we have to create a security group, which we discussed in the previous video, is guarding the instance inbound traffic and outbound traffic, and it will control that. And similarly, we'll have another security group for the backend server that will do the same thing for backend server controlling inbound and outbound traffic. We are using the NACL that is by default associated with the subnet, which will allow all inbound traffic and all outbound traffic, which of course is not a good practice, but we'll get to that in the next video. Alright, so I will go to EC2. So we are going to launch a virtual machine. So as you can see, there's no any running instances, 0. So let's click launch instance and I'm going to select an AMI or Amazon machine image, so which has operating system image where we can use to spin up our EC2 instance. So let's pick this one. Make sure to select one of the free tier eligible ones so it will not incur any cost. So let's select this one. Select the free tier eligible instance family type. So this is T2 micro and I will click configure details. So number of instances is 1 and here's the network. In which network do we want to spin up this one? So this is our web server. So let's see. So our web server is in the public subnet. So let's pick our public subnet. Before that, let's pick the whole VPC, which is this main VPC. So inside that VPC, let's pick the public subnet here. Auto assign IP addresses, and we'll click it enable because we want an IP address associated with our web server so we can access from outside, and leave all the other settings default. Let's discuss them in detail in upcoming videos, and click add storage. So this is the place where we allocate the storage for our root volume. So root volume is the volume that will have the operating system, in this case Linux operating system, and we'll leave 8 GB, which is a non-encrypted volume, and click add tags. You can add a tag name web server. So this will help you in finding out the cost incurred by the web server easily in the AWS bill. And next, click configure security group. So as I mentioned, security group operates at the ENI or Elastic Network Interface. Let's give a security group name web server SG, web server security group for the web server as the description. So what type of traffic do we want to allow into our web server? Since this is public facing web server, we have to allow all the HTTP and HTTPS traffic into our web server so that anyone can reach out to our public web server and view our website. So let's go to here, and I will enable SSH, and I will add a new rule. Let's select HTTP on the port 80 of the instance. Now this port is always the destination port. The traffic is coming from outside, from the internet into our web server onto the port 80 through the HTTP protocol. Okay, so then the source, let's give 0.0.0/0, which will represent entire IPv4 address range, and description enabling HTTP traffic from anywhere. And let's add another rule for HTTPS as well. It will allow the port 443 for all the HTTPS traffic from anywhere. What about SSH, guys? Well, of course, we don't want everyone to SSH into our web server and do whatever the things that they desire. So we will block that SSH only to my IP. So let's click my IP here, which will enable only my laptop to SSH into this web server. And now let's click review and launch. Let's review it. Well, everything looks fine to me. It will show the instance detail and the storage we attached and the tags and also the instance type. Let me click launch. And when you click launch, it will ask us to create a new key pair or use an existing key pair to SSH or remote desktop into our web server. So in this case, let's create a new key pair. So these are public key, private key encryption. So the instance will have the public key and we need to download the private key. Let's say YouTube as the name of our key, and I will download the private key. There you go, I have downloaded the private key. And now let's click launch instance. Your instances are now launching. Let's give it a second and come back to this. Alright guys, now our instance is in the running state and the status check is also passed so that we can actually use our instance. Now let's have a look at some information about this particular instance. You select the instance, and if you see the description section below, I can maximize it by clicking here. You should see there's this instance ID and the state is running right now, and the type that we chose, it is of T2 micro instance family. And see, our web security group is also applied, and all other configuration that we have configured as well as the default configurations. Now one important thing I want you to notice is this IPv4 public IP. Now if you can remember, while we are launching, we specifically mention or we specifically enable getting a public IP for the instance. Now since this is our web server, we should be able to connect it from outside. Now let's rename it. I can click here, let's say web server. So the web server instance has a public IP as well as a private IP. Now if you think about the private IP, it's 10.0.0.105. Since we have launched it under the public subnet, it has received a private IP address within that range. So what is our private IP range for this particular subnet? It is 10.0.0.0/24, isn't it, guys? So let's double check that. Look, I am in the public subnet in the VPC, and here's our VPC range. So the CIDR block assigned to public subnet is 10.0.0/24. So 10.0.0.105 is under that range. Now guys, you can explicitly say, okay, this has to be my private IP at launching time. But since we didn't do that, it has randomly picked an IP address from our range and assigned to this. And if you look at this public IP, this is the one that AWS picked from the public IPv4 IP address pool and assigned to our instance so that we can connect to this. But one thing to remember, guys, when you stop this instance, now if you come here and go to actions and stop this instance, this IPv4 address will be released. And when we relaunch it or restart it, this instance will be assigned with another IPv4 address from the AWS IPv4 pool. If we want to avoid that, we have to assign an elastic IP, which we will look at in the upcoming videos. So now let's try to connect to this instance with this public IP. I will select the instance and I will click connect. Then it will give you some instruction how to connect to your instance. Basically, you need to have a SSH client. If you are using Windows, you can use PuTTY or else any other SSH client. Since I am using a Mac, I can use the terminal itself. And it says to locate the private key, which is our youtube.pem, and then it asks us to reduce the permission level to chmod 400 for that private key. So this is for security purposes. So what does 400 means? The owner can only read it, right? I hope you guys are familiar with the Linux permissions. Now let me give you a quick refresher. chmod 400. Now very first bit or the leftmost corner bit is about the permission for the owner, and the second bit is the permission for the group. So if you have groups, so this is the group permission, and the last one is the public permission. So what about these numbers? 1 is execute, and 2 is write, and 4 is read. So any placement value, let's say the leftmost corner placement value for the user, is a combination of these three values. For example, here it's only read. Now if we want to provide read and write, then what should be the number? 4 plus 2, it should be 6. And if we want to give read, write and execute this file permission, it should be 7 because 4 plus 2 plus 1 is 7. For the group also execution permission, it's 7 here, and for public also it should be 7 here, right? So 400, it means only the read permission for the owner. So let's quickly do that. I will take a terminal and I am in the download directory, and I should have my youtube.pem file here. Here is it. Let me clear the screen and reduce the permission of the file by typing chmod 400, that is read permission for the owner. So the file name is youtube.pem. Hit enter. Great. Now we can connect to our instance using our public IP address. So it is the same thing, 35.175, and here also it's 35.175 ending with 124. So it's the same IP address. So how do we connect to it? We can use this SHSI particular command. Let me just copy this one and take my terminal and paste it in and hit enter. Do you want to continue? Yes, and hit enter. So it's adding our IP to the known hosts. Let's see if this get connected. There you go, it's connected. Can you see it says Amazon Linux 2 AMI. Now we are inside the virtual machine. Our web server starts with EC2 user. Can you see our IP address 10.0.0.105. So now we are inside our web server here. This web server is in the public subnet, and it has a route out to the internet gateway, so it can receive traffic from the internet, and also it can go to internet without any issue. So let's try to connect to internet and update some packages. shall we? Let me go to here and let's clear the screen. So I am inside my web server. Now I am connected as a EC2 user, if you can see here, because when we connect to the instance we used EC2 user at the IP address, so it is connected as the EC2 user. But if we want to like connect to the instance and get the updates, we have to increase our privilege to the root level. So how can we do that? Let's say sudo su to switch to super user. Now I am the root user. Now we can use the yum package manager of Linux to update the packages. Yum update and -y. There you go, it started downloading all the packages and we are successfully connected to the internet and receiving the updates. So now we could connect to the instance from the internet, and also within the instance also we could connect to the internet. So our security group is working fine. NACLs, of course, it will allow all inbound and outbound traffic. And let's check our security group again. If I go to web server security group and view inbound rules, web server security group and inbound rule, you can see HTTP and HTTPS is allowed, and also SSH is allowed. So we already checked SSH. We have allowed only our IP address, my laptop's IP address. So we could connect to that successfully. And within the instance, let's see outbound traffic, and outbound traffic is all allowed. So we could connect to internet and get back the results. Now, how about if I go to outbound traffic here and remove this rule and save it? When you update the security group, it will be instantly affect in the instance. So let's see if we can still connect to the internet and get the update. I will type yum update y again. There you go, it says fail to set locale, and let's try to ping google.com. Pinging google.com, well, we don't receive any data because outbound is blocked. So let's come back to our outbound rule and edit it and re-allow all traffic outbound to any destination, and allow traffic to any destination and hit save. And let's go to our terminal again, and you can see it start receiving the ping from google.com. Excellent. Now let's try to ping our instance from outside from our terminal and see if we receive a response. So under my inbound, I have only given SSH, HTTP and HTTPS, but we have not yet added or allowed ICMP traffic. Now ICMP is the protocol that is used to ping an instance. Let me show you. If I go to edit and add rule, and see all ICMP IPv4 is not yet added. So let's try to ping this without allowing ICMP traffic. Let me go back to my terminal and clear the screen. Now I'm inside the server here, and I don't want that. Let me take a new window. Okay, so this is outside the server. This is my laptop. Let's try to ping the IPv4 address. So what is the IPv4 address? This one. So let me copy the public IP of the instance and ping. Well, it is request timeout. So it is not able to ping the instance. So let's go to our security group, web server security group, and allow inbound traffic. So let's add a rule and allow all ICMP traffic from anywhere. Hit save, and now it immediately getting the response back from the instance. How cool is that? So as soon as you change the security group rule, that change will be immediately affected. Beautiful. Alright guys, so now our web server is perfectly working. So let's spin up the backend server also. I will go to EC2 and EC2 dashboard and launch another instance. Let's use the same AMI and T2 micro, number of instance 1, and the network, make sure to choose the YouTube network, and subnet. This time it has to be the private subnet because this is the database server. We don't want outside connections from the internet into our database. So that's why we put it in this private subnet. Public IP we don't want it, and leave everything as defaults, and click add storage. Okay, add tags, name, DB server, configure security group. So let's create a new security group called DB server security group. Security group of the database server as the description. So now look, if we ever wanted to connect to our database server, we cannot do that over the internet because this is in the private subnet. So how can we ever get into our DB server for, let's say, update the database version or some security patches? And also, most importantly, our web server should be able to talk to our database, right? Otherwise, there's no point of using the database server at all. Web server will receive the public facing internet traffic, and from the web server, it should be able to talk to the database and query some data and get the data and return the response back to the user. So let's go to our diagram. So in the diagram, you can see this is our backend server, and we have a security group that controls traffic into the backend server. So that is the one we are now configuring. So let's allow our web server to talk to backend server. How can we do that? We can allow the web server security group to talk to backend server. So in the EC2 console, let's add all traffic from any port, not from anywhere in the world, but from our web security group. Now if you start typing web, you should see it prompts the web server security group. So as our traffic source, we can define an IP address or IP address range or a security group ID. In this case, we attach a security group ID. So what does this rule says? This rule says allow any traffic from any EC2 instance that has this particular security group attached. So in the diagram, we have our web server here. The web server has the web server security group attached. So with this rule, it will allow our web server to talk to the backend server. And if there's another server that has the same security group attached, that server also can talk to the backend server. Clear? Allow traffic from web server SG and click review and launch and hit launch. Choose the same YouTube key. So it is the same private key for us and launch the instance. Now the instance is launching. If I go to view instance, it's still launching. Let me rename it DB server. Okay, now DB server is up and running. Select that. And if you see the description, we don't have a public IP, but only a private IP of the 10.0.1 range, which is our private subnet range. So it has big 142 IP address. So this is exactly what we need. We don't want a public IP, instead private IP. And also let's check our security group, DB server security group. And as the inbound rule, we have allowed all the traffic from our web server security group. So let's try to ping the DB server from outside using the private IP. Will that work? Of course not. Let's try that anyway. Ping. You see, you won't receive anything. This has no connection to the internet because it does not have and route out to the internet gateway, so it's totally isolated from internet. So how to connect to that? We have to connect to our web server first, and then since our web server has the security group of web server security group, it will allow to ping our database server since we have allowed all sort of traffic. So let's connect to our web server. Let me select here web server and connect and use SSHI command. Hit enter. Okay, I'm inside the web server. You see the IP address 10.0.0.105, which is the public IPv4 address of the web server. And within this web server, let's try to ping our DB server. So let's take the DB server's private IPv address 10.0.1.142 and let's try to ping that. Again, I'm inside my web server. Now I am pinging the database server IP. Hit enter. There we go. Ping is successful since we have a rule defined in the database server to accept all traffic from any instance that web server security group is attached. So what if I delete this one? So If I stop this and retry pinging, now you can't ping. See? Let me allow it. All traffic from web server security group. And if I check back, then start pinging again. So we are receiving ICMP response. Beautiful. Okay guys, now we can do the ping successfully. So how do we actually SSH into our DB instance? Let's try our normal SSH command within the web server. So I will go to EC2 dashboard and web server and pick the database server and click connect, and it will give me the SSH command. Since we have used the same private key, I can use youtube.pem, and this is the IP address of our database server. Let's copy that and come here. This is inside the web server and hit enter. And I get an error. Identity file youtube.pem is not accessible. So why is that, guys? Basically, our PEM file is not available inside the web server instance. We could SSH into the web server from our local machine inside our download folder where we had the PEM file, but once we are inside the web server, we do not have that YouTube PEM file here. Because of that, we cannot connect to the database server even if we have configured our security groups correctly. So how can we actually do that? Well, there are two options. The first option is copy this youtube.pem file into our web server into a particular directory. So within that directory, we can SSH into the database server. It will be successful. But the best practice or the security good practice is not to have private keys saved inside instances, because if somehow an attacker gets into this instance and if this private key is exposed, then you are at risk, because you might have used the same private key for so many number of servers. So all those servers will be compromised. So the best practice is to use SSH agent forwarding. In SSH agent forwarding, what you will basically do is that you will forward the private key to the web server. So in the web server, you can SSH into the database server. So it's basically passing the private key onto the web server during the time the connection is established. Once the connection is terminated, then the private key is no longer there in the web server. So you don't have to worry about attacker hacked into the web server and capturing those private keys. However, remember that still attackers can hack into the web server and get the private key during the time you are connected to the web server from your local server. But anyway, this is way better than storing the private key inside the EC2 instance, right guys? So let's do that. So I'm going to exit into my local machine. So now I am in my local machine. I'm in my downloads folder. Now I am using Mac. So in Mac terminal, SSH agent is already available. So if you are using Windows, you can use PuTTY. In Linux also, you can use a suitable SSH agent. So the first step is that we need to add our PEM key or private key into our keychain. So let's add that. Now our SSH agent is referred by ssh-add. And let me show you one other thing. If I type ssh-add/l, it will show all the private identities that currently exist. So you can see there's no any private keys associated with the agent yet. So let's add one. We type ssh-add dash capital K, then I will add my youtube.pem file. Hit enter. You can see it says identity added youtube.pem. Let me clear the screen and let's try ssh-add-l. There you go. We have our private key. Now let's connect to our web server within our local machine. Earlier the command that we used was something similar to this: ssh-i, then the private key, and then the IP address of the web server. But this time we don't have to specify the PEM key, because SSH agent is going to go through all the keys associated with the keychain and find the matching key from the keychain. So let's see that. So now I'm going to connect to the web server. So let's type SSH-A. So earlier it was I. Now this time on you have to use A, capital A. Then you don't have to specify any private key, but just the IP address of your public web server. Let's go to our public web server here. This is our public IP address, and if I click connect, you have to add the prefix EC2 user. So let me copy that and paste it here. So SSH capital A EC2 user at the IP address. Hit enter. Awesome. We are connected to our web server. Now we are inside the web server. You see our private IP address of the web server. Now let's check whether SSH agent forwarded that private key. Let me type SSH-add-L. There you go. So this is the private key that SSH agent has forwarded onto the web server. Now we should be able to SSH into our database server inside the web server without having to face any issues, as we already have the private key within the keychain. So let's try that. So I will go to database server here and connect, and let me copy the last part here, and in the terminal let me clear the screen and type SSH dash A. It's not I, it's A, and then the IP address of our DB server. Hit enter. There you go. Now we are inside the database server. Can you see the IP address? It's 10.0.1.142. So which is the private IP address of our database server. Beautiful. So guys, this is what I want to show you in this video. So this is the recommended way to connect to your private instances via SSH. Now that we are inside the database server, let's try to run a yum update. Let me type yum update-y, hit enter. Well, it failed. Why it failed? Because it does not have any internet connection. So now we got another issue. Somehow we got into the database server, but still again we cannot download the security updates or the database update from the internet. So what's the solution here? We have to have a NAT gateway or a NAT instance in the public subnet where our backend servers can talk to internet via the NAT gateway or the NAT instance. So we have to place the NAT gateway or a NAT instance in the public subnet. Why is that? Because in the first place, NAT gateway or NAT instance has to have the internet connectivity. So that's why we put the NAT gateway or NAT instance inside the public subnet. Then what we will do is we are going to add a new route to our private subnet route table. Now if you can remember, we had two route tables, one for the public subnet and the other one for the private subnet. So our public subnet had two records. First record is routing within the VPC or the local route, and then any other IP address will resolve in the internet gateway or route out to the internet gateway. So those were there in the public subnet. That's fine. But in the private subnet, we had only one, that is the local route. So now we are going to add another route. That means any other IP addresses other than our VPC IP address range should go to the NAT gateway or the NAT instance. So when our backend server, let's say it's a database and it's an Oracle database and it wants to grab some security updates from the Oracle website. So Oracle website IP addresses is not within the CIDR or the IP address range of our VPC. So what it will do is it will route that request to the NAT gateway. So it will go in this direction. It will first reach the security group. It is allowed from the NACL at the subnet level. It is allowed, and then it goes to the router, and the router will use the private subnet route table and check whether it is within the VPC CIDR block. No. Then it evaluates the second rule, which route it to the NAT gateway. So it will route to the NAT gateway, or this could be a NAT instance. Now the NAT instance or NAT gateway is in the public subnet. It will do network address translation. So it will save the private IP address of the backend server which the request was made, and it will use the public IP or the elastic IP of the NAT gateway to connect to internet via the internet gateway and go to the Oracle site and get the update and come back here and then send that particular payload to the private IP address which was saved earlier, which is our backend server. So let's discuss this furthermore in a bit. So basically, there are two ways. First one is the NAT gateway, and the other one is NAT instance, as I mentioned. So now let's see the differences between these two. If we do a quick comparison with NAT gateway and NAT instance, availability wise, NAT gateways are highly available because these are managed by AWS guys. So NAT gateways are inside the availability zone and it is implemented with redundancy. But NAT instance, it is something that you create. You use an instance which support NAT functionality. What is the NAT functionality? You know that mapping between private and public IP address. So you have to find an instance that supports that, right? And then you will spin up that instance and you have to manage the high availability by yourself. For example, you have to add multiple NAT instances and do a failover using a script or so. Then when it comes to bandwidth, the NAT gateway supports up to 45 gigabits per second. And the NAT instance, since it's a normal EC2 instance, it all depends on the instance type. Maintenance wise, NAT gateway is managed by AWS and the NAT instance is managed by you. So installing software updates, everything you have to do by yourself. Public IP addresses, well, both NAT gateway and NAT instance must have a public IP address. So that is the one which connect to the internet and get whatever the payload and come back and then do the netting, right? So it has to have the public IP address. But especially in the NAT gateway, it must have an elastic IP address. So this is a must. So you have to assign an elastic IP address and it will not accept any public IP addresses. And another thing is once you have assigned elastic IP address and created the NAT gateway, you cannot disassociate that elastic IP address. Whereas in NAT instance, you can have either elastic IP address or public IP addresses. And also you can change, for example, let's say you assign a public IP address at creation of the NAT instance and later on you can change it to a elastic IP address as well. Private IP addresses, so both will select the private addresses from within the subnet's IP address range. And security groups, you cannot associate a security group with a NAT gateway. Since this is a managed service from AWS, you don't have control over it. So you cannot associate any security group. But however, you can associate security group with your resources, like let's say EC2 instances in your private subnet and do some control over the traffic that it receives or send. But in NAT instance, since it is managed by you, you have to associate a security group and you have to make sure the right security group rules are associated. For example, both NAT gateways and NAT instance should not allow traffic outside the internet to get into the instances. So that should not be allowed, right? So that you have to make sure those security groups adhere to those rules as well. So we'll discuss about this in a bit. And also network access control lists. Yes, both of you can use NACLs because those are operated at the subnet level. So you can use it to control traffic for both NAT gateway and NAT instances. Remember, both NAT gateway and NAT instance operate within the subnet. So you can associate NACL to control the traffic. And can we use NAT gateway as a bastion server? No, you cannot use the NAT gateway as a bastion server. What's the bastion server, guys? Basically the other way around. Whether or not you can like designate a particular set of IP address range to SSH into your private instances via the NAT gateway. You cannot do that, but you can do that with NAT instances. We'll get into that in a bit as well. Okay, now let's look at more information about NAT gateway. NAT gateway, as I previously mentioned, it has to be in the public subnet. Why? It has to have the connection to the internet so that it can provide internet to the private instances that is in the private subnet. So once you have set up a NAT gateway in the public subnet, you have to do few things. The first one is you have to associate an elastic IP address because NAT gateway only supports an elastic IP address. So this is the public IP that it used to connect to the internet. And then you have to update the route table of your private subnet. So look at this route table. So the rule that we have currently in the private subnet is the VPC CIDR block or any IP address within the VPC routing within the VPC, or we call it local, right? So what about the other IP addresses that is not within the range of VPC? So we have to add this new route. That means any IP addresses which is not within this CIDR block has to go to the NAT gateway. So we denote it by NAT Gateway ID. So this NAT Gateway has a NAT Gateway ID. By specifying this rule in the route table, it will make sure to do the necessary routing to the NAT gateway whenever a IP address is found which is not within the VPC CIDR block. So our database server, let's say our database server want to grab some update from Oracle. Oracle website of course have a IP addresses which is not belonging to our VPC CIDR. So what will happen is that request will first go through the security group and NACL will again allow it, and it will go to the router here, and from the router it will inspect the private route table or the route table assigned to the private subnet. So it will check whether it's within the VPC. No. Then it will use this rule which will route that traffic to the NAT gateway. So from here it will go to the NAT gateway, and NAT gateway then here it will does the netting. So it will record the private IP of the backend server and use the elastic IP that is assigned to the NAT gateway to go to the Oracle website via the internet gateway and grab whatever the updates that it needs and come back to the NAT gateway. So once you have the payload, it will forward that payload onto the private IP address of the backend server which was saved earlier. So what will happen is the private IP address will receive the payload and it will go back to the router, and the router again check the private route table, and now the IP is within this range, so it will route it locally or within the VPC. So it will go here to the NACL or network access control list, and it will allow the inbound traffic. So it will go to the security group, again the security group will allow it, and it will then reach to the backend server IP address with the payload. So now our database can receive the updates from the Oracle website. So what are the three things that we need to set up a NAT gateway? First, you have to have a public subnet. Now this is really important, guys. You have to have a public subnet for your NAT gateway, so it has internet connectivity, and you have to assign a elastic IP. So this is a must. You have to assign an elastic IP, and then you have to update the route table of the private subnet. We'll do a quick demo in a bit, but before that, let's look at NAT instance as well. So NAT instance, it's a EC2 instance. It supports NAT functionality. So you spin up that EC2 instance in the public subnet, just like the NAT gateway, because NAT instance has to be in a subnet which has internet accessibility. And then you will add the same route, which is the any route 0.0.0/0 pointing to the NAT instance ID. So in terms of traffic flow, it is more or less the same. When the database servers want to get the update from internet, it will first go to the router, and the router will check the private subnet route table. Since the website that the database servers are trying to reach is not within the VPC, it will route that into the NAT instance. So the traffic will go to the NAT instance, then the NAT instance will do the network address translation, and it will use the elastic IP or the public IP that is assigned to this. Now remember, NAT instance can have both elastic IP or public IP. So it will use the public IP or the elastic IP that was assigned to it. It will use the internet gateway to reach out to whatever the website and grab the update from that. When it comes to NAT instance, we have to manage it. Specifically, we have to add a security group for the NAT instance to control the traffic in the NAT instance. So now let's look at the recommended rules for the NAT instance that is given by AWS. Now, as for the recommended security group rules, it is recommended to allow inbound traffic from the private subnet IP address range, because our NAT instance should be able to receive traffic that is originated from the private subnet IP address range. So now assume this is the private subnet IP address range 10.0.1.0/24. You have to allow both the 80 and 443. So this is basically allowing both HTTP and HTTPS traffic that is generated within the private subnet, right? And also there's another rule. So this is basically the public IP address range of your corporate network. So why do we really need this one? Now let's assume you want to SSH into your NAT instance and use that NAT instance as the bastion host or the jump box to jump into your private instances. Now this is one of the differences that you might have remembered from our table earlier. the NAT gateway, you cannot use it as a bastion host, but NAT instance you can of course use it since you are controlling security of the NAT instance. Well, when it comes to outbound, we are allowing all the traffic that is outbound to internet or any other IP addresses on port 80 and port 443. So our NAT instance can send traffic out to the internet without any barriers. Alright, now in NAT instance there's one particular thing that you must remember. I told you that NAT instance is nothing but another EC2 instance. Now in the EC2 instance, there's this source destination check that is enabled. Now what is this source destination check, guys? Now source destination check always verifies the traffic that an EC2 instance sends or receives is either originated or destined to the EC2 instance. Let me reiterate again. The source destination check verifies if the instance is the source or the destination for any traffic it sends or receives. So if some traffic is sent out to the internet, it has to be originated from the EC2 instance. If some traffic is coming into the instance from the internet, it should be destined to the EC2 instance. But in NAT, we have to violate that rule. In NAT, you're basically not initiating the traffic that is initiated at the NAT instance. It is initiated at the backend server. What NAT does is it will basically translate the IP addresses into the elastic IP or the public IP and then send it on behalf of the private instance. So if some traffic is sending from the NAT instance, it is not originated from the NAT instance but the backend server. And vice versa is also true. If some traffic is received to the NAT instance, it is not designated to the NAT instance but to the private instance at the backend. So in order to cater this, you have to disable source destination check. So this is a really important thing. You must disable the source destination check. Alright. Now AWS always recommend to use NAT gateway instead of NAT instance because it is fully managed and you don't have to specify security. AWS will handle the security for you and NAT gateway is a redundant service. Now let's do a quick demo on NAT gateway. Alright, now I'm in the AWS console and this is the VPC that we have created a few tutorials back. If I go to the EC2 console, in the last time we spin up two EC2 instances. One is web server and the other one is database server, where the web server was in the public subnet and the database server was in the private subnet. And we attached two security groups to these two servers as well. Web security group for the web server and database security group for the database server. And we allowed all HTTP and HTTPS traffic from anywhere in the world to the web server. Because it is a web server, it has to receive traffic from anywhere and should serve the website. And we only allowed the traffic that is coming from the web security group to have access to the database server. And we only enable SSH from my laptop to the web server security group. And since we allowed all the traffic that is coming from the web server security group to the database server, it will allow SSH from our web server to the database as well. Am I too fast? Let me quickly show you that. I will go to a terminal. I have my private PEM key here in this particular folder. And let's try to SSH into the web server. We can do that because this is a EC2 instance in a public subnet. So I will select this and I will click connect and use this. Instead of using SSH-I, I will use SSH agent forwarding. So how can we use that? First we need to add the private key into the keychain with SSH-add command. Let's do that. SSH-add-k for the private key and yt.pem, hit enter. See, identity is added. And now let's connect to this DNS name of our web server. I will type SSH-a. Instead of I, we are going to use A here because now we are using the SSH port forwarding and use the DNS of the web server, hit enter. Or you can use the IP address as well. Alright, now I am in the web server. As you can see, the web server IP address 0.0.0.79, which is the web server's private IP address 0.0.0.79. So within this, let's try to access our database server. So I will clear the screen and I will select the database server and click connect, and I will use the DNS name here and use SSH-A, which is agent forwarding, and hit enter for private IP address of the database. Now as you can see, it is successfully connected. Look at the IP address 10.0.1.7, which is 10.0.1.7, the private IP address of our DB server. Now we are within the database server instance, right? So what about if we try to ping google.com? Can we do that? No, we don't receive any ping. And how about we try to do some yum update that will receive latest updates for Linux. Let's hit enter. Nope. It says you need to be root. Okay, let's try to be root and do that. I type sudo -su and now again type yum update -y. As you can see, it is stuck. See, it is not able to connect to internet and get whatever the updates. So this is the issue that we are exactly trying to address with NAT Gateway and NAT instance. So now what I'm going to do is I'm going to create a NAT Gateway. So I will go to my VPC. So this is the VPC dashboard. And if I scroll a little bit down, I should see NAT Gateways here. Click that. And now click Create NAT Gateway. So what are the 3 steps that we have to follow? First one is select a public subnet. Now it will show only the subnet ID. So we have to pick the right subnet. Now let me go to our VPC in a different tab and let's exactly find our public subnet. We'll go to your VPCs and I will filter my YouTube VPC here and I will go to subnets. Now this is our public subnet, so that is ending with 0FF7. So go back to the previous screen and select the one that ends with 0FF7, this one. Alright, so this is the public subnet. Now the next step is associate an elastic IP. You see, this is a required field. You cannot create NAT gateway without an elastic IP. Now I don't have any elastic IP allocated at the moment, so I will click create new EIP or elastic IP and associate it with this NAT gateway. Alright, so it is created and associated successfully. Now I will click create NAT gateway. Okay, what's the third step, guys? So it is about editing the route tables of our private subnet. So let's do that. I will click edit route tables and I have to select private route table here. Go to routes, and as you can see, currently we only have the local VPC route which is targeting the VPC itself. So any IP addresses within the VPC will route to the target VPC, and I will click edit and I will add a new route which is 0.0.0/0, which is all IPs except any IP falling this range. And here as the target I will select NAT gateway and it will show me the NAT gateway ID here. Select that again and then save the routes. Alright, okay, so now our private subnet has a route out to the NAT gateway. So let's go to our terminal again. Now I'm still within the database server which is within our private subnet. Now let's try to ping google.com from within our database server. As you can see, the ping is successful. You get the response ping. Let's stop here and let's try to run yum update -y to receive updates to the Linux and hit enter. Okay, I think no packets marked for update, so that means it got the updates already. So we could successfully connect to any website and it seems our NAT gateway is working. So let's try to ping another one. Ping yahoo.com. That works too. Beautiful. Okay guys, so how about I will remove this route from the private subnet. I will click edit the route and I will delete the route out to the NAT gateway and save routes. Okay, it is successfully saved. So let's go back here and let's try to ping yahoo.com again. Okay, ping is now stuck because it cannot reach out to the internet. It cannot send the ICMP traffic. Great. I think now you understand why do we need a NAT gateway or a NAT instance and how to create a NAT gateway. Now before concluding this video, I want you to make sure that you removed the NAT instance or the NAT gateways from your VPC. Otherwise you have to pay for the NAT gateway. So go to NAT gateways, select actions and delete NAT gateway, delete NAT gateway. Okay, it is deleting. So make sure you do that to avoid any costs. And also after it is deleted, go to Elastic IPs here and select the Elastic IP that we initially allocated for the NAT gateway and go to actions and release that. Alright, I think that's it for this video and I'll see you in another video. Thanks.